Greetings, NetSteppers. In this CCNA video cheat sheet, we'll be covering cabling, specifically straight-through, crossover, rollover, and serial cables. To connect any device, you need an interface, a connector, and a cable. Let's look at the forest slide. In the upper left-hand corner, we have a picture of an unshielded twisted pair or UTP cable. The UTP cable is not one solid thick copper cable. It is actually made up of 8 smaller copper cables, all held together by an outer sheath. Each copper cable is paired together with another copper cable, forming a pair. So instead of 8 individual cables, you have 4 pairs. The individual cables that make up a pair are twisted around one another. For example, the solid blue and half blue white cable pair is twisted around one another for the length of the cable. By twisting the cable pairs in this manner, it cuts down on electromagnetic interference, or EMI. That is how it got the name unshielded twisted pair. In the right-hand corner, we have a picture of an RJ45 termination connector. RJ45 connectors are used to terminate UTP cables in RJ45 interfaces. They can also terminate other copper cable types, but we will remain focused on UTP cable. UTP cable and RJ45 termination connector are traditionally used in Ethernet networks, but can be used for other connection types. In the lower middle, we have a picture of the DB60 serial cable. Traditionally, this cable and termination type was utilized in WAN connectivity. The cable gets its name from the 60 pins on the male end of the connection, or the 60 receptacles on the female end. Let's dig a little deeper and look at the tree slide. The picture on the left is an example of a straight-through cable. You now see the twisted pairs broken out into individual troughs. Also, this slide gives you some insight into how the RJ45 connector works. Looking at the upper left picture, the left RJ45 connection, you may notice that position 1, the white and green striped cable, corresponds with position number 1 on the right RJ45 connector. Continuing with the upper left picture, the left RJ45 connection, position number 2, the solid green cable, corresponds with position number 2 on the right RJ45 connector. This pattern continues for the rest of the cable positions 3 through 8. Even though the pairs are twisted inside the cable, the correct position on one end matches the same position on the other end. That is why it's called a straight-through cable. If this is not clear, the left side of the lower picture also demonstrates a straight-through cable. The picture on the right is an example of a crossover cable. Same cable, same RJ45 termination connector, different termination endpoints. Where a straight-through cable went straight through position 1 to position 1, a crossover cable crosses the transmit and receive pairs. Looking at the upper right picture, the left RJ45 connection, notice that position 1, the white and green striped cable, corresponds with position number 3 on the right RJ45 connector. Continuing with the upper right picture, the left RJ45 connector, position number 2, or the solid green cable, corresponds with position number 6 on the right RJ45 connector. In summary, a crossover cable connects position 1 to position 3 and position 2 to position 6. Crossing the transmit and receive ends causes it to be called a crossover cable. If it is still not clear, the right side of the lower picture also demonstrates a straight-through cable. When would you use a straight-through cable versus a crossover cable? The next tree-level slide answers that question. On the left, we have straight-through cable examples. If you connect the switch to a router, you need a straight-through cable. If you connect a switch to a server, you need a straight-through cable. In most instances, if you go from a device to an unlike device, you need a straight-through cable. On the right, we have a crossover cable examples. If you connect a switch to a switch, you need a crossover cable. If you connect a router to a router, you need a crossover cable. In most instances, if you go from a device to any like device, you need a crossover cable. It all boils down to the transmit and receive connections on each end. If you connect a switch to a router, they transmit and receive on different connections. Therefore, you have to use a straight-through cable. If you connect a switch to a switch, they transmit and receive on the same connection. Therefore, you have to use a crossover cable. The picture on the left is an example of a rollover cable. Same cable, same RJ45 termination connector, different termination endpoints. Where a straight-through cable went straight through, position 1 to position 1, and a crossover cable crosses the two transmit-receive pairs, a rollover cable rolls every cable pair. Looking at the upper left picture, the left RJ45 connection, you may notice that position 1, the white and brown striped cable, corresponds with position number 8 on the right RJ45 connector. Continuing with the upper left picture, the left RJ45 connection position number 2, the solid orange cable, corresponds with the position number 7 on the right RJ45 connector. This pattern continues for the rest of the cable positions 3 through 6. In summary, a rollover cable literally rolls all of the RJ45 positions. The picture on the right is an example of a serial cable. These cable types are not as prevalent as they used to be. They would connect a router to an external telecommunications device known as a Channel Service Unit, or CSU. Today, most CSUs are built into the interface card, therefore you don't need this cable type, but you still need to know about it. Wink wink, nod nod, say no more. I want to stop and have a reality check. On this slide, we'll talk about the difference between academia and the real world. In academia, you need to know the difference between a crossover and a straight-through cable. In the real world, most routers and switches contain logic to automatically detect the cable type, such as crossover cables, and allow them to function with other types of Ethernet devices. In academia, you need to know how a rollover cable works. In the real world, just about every device comes with a console cable or a rollover cable. In academia, you need to know about a DB60 cable. In the real world, what? I have not seen a DB60 cable in like 20 years. Now that does not mean that they are still in use, and if you have one in your network, I do not mean to offend. Most networks today have gone to Ethernet as their preferred transport. As an aside, when I first got into this industry back when routers were made of stone, I worked at a very small enterprise. They had frame relay and DB60 connections, by the way, and I was tasked to lab up some Ethernet connectivity solution. For 2 days, I tried to get those connections to work, and finally I went to the senior guy, and he asked me, quote, "Are you using crossover cables to connect the switches together?" End quote. Nope. Lesson learned. At the next job, I was tasked once again to lab up an Ethernet solution, and I spent a day creating the proper cables. The senior guy came by to check on me and asked, quote, "Why are you doing that? The switches auto-detect." End quote. Lesson learned. Let's dig a little deeper and look at the leaf slide. It is now time to see what you've learned and introduce some specific concepts with the next step challenge. Assuming everything is IP'd correctly, will these devices be able to ping each other? No. A crossover cable should have been used in place of the straight-through cable. You can't go from device to like device with a straight-through cable. Like to like, crossover. Like to unlike, straight-through. Staying at the leaf level, we have another next step challenge. What kind of cable should be used to make each connection that is identified by the numbers 1 through 4? Number 1, an Ethernet straight-through cable. Number 2, an Ethernet straight-through cable. Number 3, serial cable. And number 4, a rollover cable. Staying at the leaf level, we have our final cabling next step challenge. To what type of port would a cable with a DB60 connector attach? A serial port.